Hey everybody, I'm Josh Badeska. I'm the Chief Data Scientist at Domino Data Lab, and I'm very pleased to be moderating this session today. And Domino is pleased to be hosting this session. Before we introduce our speakers, I'd like to briefly introduce you to Domino and tell you what we're all about. Organizations today have a wonderful opportunity in front of them to take their teams, their companies, into the next era, the modern future of data science work. But there are many challenges to get there. And it's time, we believe at Domino, for the C-level suite, chief data officers, chief information officers, and such to take charge in implementing best practices, to take charge in consolidating technology platforms, to allow your teams to reach their highest potential, and to allow the business to really start to realize the results and the promises that we all hear about ML and AI. And Domino's built a data science platform to help make that a reality. It's trusted by more than 20% of the Fortune 100 to centralize data science work and to centralize and govern infrastructure across the enterprise. It allows for collaboration. It allows for quick deploying and easy management of models. With Domino, data scientists are more effective. They innovate faster. Teams can collaborate together and research together. And IT can manage this entire data science sprawl. If you've ever tried to do this, to implement data science at scale, to scale it across the enterprise, you know it's hard. Friction points often come up. Three of them that we see quite often at Domino are infrastructure friction, DevOps needs around packages, tools, data connections, IT and data science having a little bit of conflict, always going back and forth in this infrastructure phase. Lack of knowledge management, the inability for data science to recreate and to reproduce past research. The inability of data science leaders to truly manage a portfolio of data science projects and to know what value is coming from each of these assets and projects that are underway. And the last mile problem of getting data science work, data products into production. Domino is helping to solve these friction points, solve these problems for our customers by consolidating all the work into a single data science platform. And in this platform, we know that data scientists are not our only customers. It was built for data scientists, but also for data science leaders and for IT. For the data scientists, they get self-service access to infrastructure, whether that is CPUs, GPUs, clusters, any open source technology that they like R and Python and different IDEs, Jupyter, RStudio, VS Code, even proprietary IDEs that your company might own like SAS and MATLAB. For data science leaders, they get access to metadata reports and dashboards that help them see the big picture of what's going on in data science in their organization, who's working on what assets are in production, where are projects at in their life cycle, who's collaborating, how can we foster that collaboration, how can we help with more reproducibility. And for IT, it's reducing the need and the footprint needed to maintain a modern, secure data science platform. It eases the burden on IT, allows them to govern and bless certain actions that then data science can then do for themselves. And how does Domino do this? The Domino platform basically consists of four main areas. The first being the workbench. This is where data scientists go to do their R&D and their experimentation. Next is model ops. This is where we deliver on that last mile, getting models into production so they can create that business value. Underpinning all this is an enterprise hardened infrastructure layer where the scalable work and the managing of resources happens. And at the top of all this, kind of overseeing it all, is a knowledge center, a place where data scientists can collaborate, can search, can reproduce work, can share environments, can share code, can share projects, and can really start to treat their teams like a research group. And I mentioned it before, but I'll say it again because it's so important. The Domino platform and any data science platform has to be open. And by open, I mean you have to have access to data sources. You have to have access to different languages, to the tools and IDEs that data scientists like, to the packages and what's going to be coming that's new and latest and greatest. They need access to Spark on clusters, but they also need Dask and Ray and any other new compute accelerators that are going to come. And importantly, this needs to be available both on-prem and on the cloud. A data science platform can't lock you into one way of working, to one architecture. In a nutshell, Domino provides a system of record for data science work. So as you can see, helping organizations be successful with their data science initiatives is what Domino is all about. And that's why we're excited to be hosting this session today. So let's jump into it. All right. Hey, everybody. Welcome to the fireside chat portion of our presentation here today. As I mentioned in the intro, I am Josh Podeska, Chief Data Scientist with Domino Data Lab, and I'm very pleased to be moderating the chat, and Domino is pleased to be hosting. We're joined today by two special guest speakers and we have a great set of questions to dive into data science, how we can accelerate it, accelerated data science, and unlocking your model velocity. So let's start by introducing our speakers. We have Mina and Sean joining us. Sean, do you mind introducing yourself first, and then we'll go to Mina next?
Sean Otto, Director of Analytics at AES. AES is in the renewable energy business. We're the 5th global largest producer of renewable energy outside of China. We own a few utility companies also.
Great, thank you. And Mina.
Hello, everyone. I'm Meena Thanikachalam, Head of Data Strategy and Architecture at Ally Financial. Ally is the leading digital financial services firm. Doing it right for our customer has been our focus. Looking forward towards this conversation.
Yeah, great. Thank you. Thank you both for joining. So let's jump right in. In data science, I often like to say that you see two basically types of projects, and they exist on a spectrum, on a continuum. But on one side, you have the home runs, the big splashes, transitional, transformative changes, projects that really catch everyone's eye. And on the other side, you have small incremental improvements, operational efficiencies. And those sometimes can add up in the aggregate to be more valuable than the big home runs. I'd love to maybe spend a few minutes talking about use cases just to kind of level set our conversation as we dive deeper into model velocity. Mina, do you mind starting and sharing a few use cases that you've seen that kind of exemplify the way data science adds value?
Yeah, data science has impacted many industries, specifically to your point, the home grown use cases that we commonly see in data and analytics industries are many-folded, but I'll try to give a few examples here. So when we talk about data and analytics, protecting our data is very important for any organization. And so one of the common use case of where machine learning could be applied is to proactively monitor any data security challenges or issues and be able to notify our data owners. That's been a common use case in the industry that I have seen. In fact, the cloud computing providers are able to offer this capability as a service that you could deploy and get started very easily. Another use case that I commonly see in the industry is around data quality monitoring. Gone are the days that you would be constantly looking at just implementing the rules, but then the DQ monitoring is also enabled through machine learning. Many of the vendor-based products are offering machine learning built DQ monitoring capabilities that will proactively monitor data quality issues and will notify the data owners about bad quality data. And that's been a common use case in many organizations. So when we look at other use cases where machine learning has transformed the business, is multifolded. In manufacturing, for example, you could say that there is a lot of awareness and proactive measures to be taken when it comes to predictive maintenance of an equipment or a vehicle, and also warranty management. So that's one common use case in manufacturing. If you look at retail, there's plenty of use cases, but one of the common thing that we can see is like inventory planning. So machine learning can help proactively monitor your inventory depending on the season and also the events. And if it's a holiday season, it can proactively guide you on what sort of products to be stocking up. So that's a common use case in retail. In healthcare, we see a lot of use cases when it comes to understanding patients' diagnostic test results and be able to proactively predict the possible disease that a patient can anticipate or a condition that the patient can go through in future. So there's a variety of use cases in every industry. Like even if you look at insurance, there's a lot of benefits for actuaries to be able to predict the risk involved in underwriting. That's one common application of machine learning. And also, if you look at the insurance industry, claims processing is one of the common use case. And machine learning can help predict fraudulent transactions. So that's another use case in the insurance space. So in all industry, there's a variety of use cases where organizations are making use of machine learning to make an impact to their business, thanks to machine learning. And it's impacting our business community in all possible ways. And data and analytics, I would say, has been the backbone for machine learning.
Yeah, great. Thank you, Meena. That's a great survey, kind of a broad survey of a lot of the impacts we're seeing in data science. Sean, you're in the energy sector. What use cases are you seeing where data science brings value? And then as a follow-up question for you, maybe we could start to jump into how long it takes your organization to build and deploy these great applications. You're on mute, Sean.
Sorry about that. We own a few solar plants up in the Northeast area, and in Northeast of America, we have snow. And when a technician is monitoring one of the solar power plants there, and snow goes on it, it throws all of the sensors into array. And we typically don't have people on site, and so you have to go out there, travel, identify, is there really snow? And we've designed a set of models to alert the technician of the potential that this is actual snow on the solar panels, and how fast is it melting and so forth. And these may be, to your point, not necessarily transformational, but it's an incremental improvement upon the operation of that solar power plant. And if you have 200 of these, it adds up very fast, because when you're managing at scale, and I think we find in the renewable energy business that there's a lot of assets out there. And when you start managing at scale, that's where you find a lot of these small little incremental improvements really adding value in the business. And to the second question that you asked, how do we go ahead and deploy and monitor our models? How long does that take? And that's a good question. You know, you take after you get a business question, you put that together, you've got the design of the model, and that's a little bit flexible because it really is a science endeavor. Then you move into deploying. And we've found in our business, it takes us about 28 working hours to deploy a model. And that's validating, testing, and verifying. And then on maintaining that model, it depends on the model. We're using Domino to manage the models that we build. Our data science team leverages it very effectively in the design, and in some of the deployment, we leverage it also, and enabling it for the consumption down layer for our business consumers. And you know, the challenge that I find is 28 hours is a lot to do, and that 28 hours of actual development work can take place between 2 weeks to 3 weeks to 4 weeks, depending on how much time that data scientist has available to dedicate to that specifically.
Yeah, interesting. Maybe I could dive a little bit deeper into that. So in that process, there's the end-to-end cycle of building these data science models. And you mentioned the validation piece as being an important, I'm glad you mentioned that, because that's something I think as an industry, we need to focus on more, is that model validation. Too often that's not given the due diligence it needs. But maybe you could speak to the broader life cycle. What bottlenecks are you seeing in that process? And I think our audience might like to know any best practices or anything you found to overcome those bottlenecks to production.
Bottlenecks, or you could call them constraints in a process. And data science really is a process. You start with finding data, gathering data. We have two separate teams of data scientists and data engineers. Our data scientists work with the business and identify what data is needed. They hand that off to our data engineers, who work very much in a development sprint-like framework. And then when that data pipeline is made available, then the data scientists just jump in and start moving. So I found it very effective for accelerating our work by diverging those two different groups of activities. It lets the data scientists really focus in on the model development, And then the deploying that and working with the business directly is how they want to consume that. I think you talk about other constraints in there. Finding the right model can take time. There's a lot of tools out there on the auto ML side that are very efficient to getting you 80% of the way there and saying, go down this route because everything else doesn't work. There's other tools out there like feature stores that would be leveraged to generate thousands of features that you can then test against. And you talk about how do we minimize those constraints so that we can get velocity and not only building, but deploying and leveraging those models. I think the key is really how do you move faster so that the ROI is more visible to the business? And then afterwards, how do you maintain that? And the constraints I see around maintaining the models are making sure that we've got systems in place that are monitoring not necessarily the business metrics or the business KPIs, but I would refer to them as data science KPIs of a model. Is there drift going on? Where's that drift? Have we done a reevaluation of that? Retrained it? When was the last time we retrained it? Did any features pull out differently in that retraining? So I think it's a process that the industry, as the data science industry, I would say, is slowly figuring out that when we add this programmatical stuff on top of it, we're going to empower our ability to be more, to maintain the value of what we build for the business.
Mm-hmm. No, that's great stuff. And I mean, I have a similar question for you. And before I ask that, just, Sean, that's something that I know myself in the role I play at Domino, I'm really focusing on trying to figure out what steps, what tools, what best practices do our customers need in order to get that velocity going, right? And in order to programmatize kind of the data science lifecycle. And so, Mina, if I could ask you a question along a similar vein, we're talking about model velocity, might be a way to describe what we're talking about. How do you think about model velocity, and what have you seen to be effective in achieving that high model velocity? Because I feel like that might be what separates the winners from the losers in this coming decade of data science work.
Yeah, so it's multifolded, I would say, when it comes to model velocity. The first thing in the modeling process is to make sure that we have the right data. That is the backbone of any work that you're going to do. If you don't have the right representation of data, no matter how sophisticated models you have, not going to help. So making sure that you can do data preparation, making sure the data is of good quality and fidelity is very important. And also making sure that you were able to trace the data and be able to get the lineage, metadata, cataloging, all of that. Those are some foundational capabilities that an organization should invest in. Sean mentioned that there is groups within the organization that does data engineering and also data science type work. So it'll be good for all the teams to collaborate, work closely. That's another thing that I would mention. And so when it comes to acceleration and speed to market, so there's also technology choices available that can help share some of the work done by one analyst community or one analytical community to another community across the organization. Feature engineering, for example, if you extract features, there are technology choices available to share the features across multiple groups so that you don't need to reinvent the same thing over and over again. And that's another best practice that the industry is moving towards. So you can share and use the foundation laid by one group and use it across the organization. That can help accelerate a lot of work that a data scientist would invest in. And also, so when it comes to the actual process, there's a lot of process inefficiencies that we see, like along the way when a model gets generated or developed, and then it needs to go through the testing cycle. There needs need to be an approval process, and then there is like a model validation and risk management function in many organizations that does the assessment. And on top of it, like we also look into a lot of challenges when making sure that there is no bias in the model. That is one of the critical things that many organizations are very particular about, and they have to make sure that they debias any of the biases. There's frameworks available, open source frameworks available that can help you accelerate that, you can use AIF 360, which is open source, and you can run the framework to see if there is any bias with regards to the model. And then comes the model deployment process. From the time the model gets developed till it gets deployed, there's a sequence of steps, because you're essentially looking at multifunction to make this happen. Data engineers might be involved, data scientists and analyst team will be involved, and the model risk management function could be involved. And then there is also a platform and sustain function involved. How can we continually integrate everything and continuously deploy? And this capability within DevOps, or a branch that's evolving called MLOps, that the intent of this capability is to reduce the operational inefficiencies by the time a model gets deployed to production, from the time it gets developed. So that MLOps is a capability that many organizations is also looking at holistically to see where are the inefficiencies. MLOps by itself is not just the integration pipeline or the DevOps pipeline, but it's also around process. Like to Sean's point, there's a lot of steps and process, and where is the work held or stuck? You need to have that process transparency, and there should be a workflow to understand like where is this stuck, or where we are spending more time. So that sort of evaluation can help accelerate and provide speed to market, and also making sure that you can reuse some of the features can also help accelerate the work across the enterprise if it's a broader organization. These are some best practices. Overall, I would say if you have the right data, 30% of your work is done, because if your data is representative of all the scenarios that you could think of, then you don't have to worry about any biases, right?
Right.
And also when the model gets deployed in production, you have to constantly monitor the health of the model. And there's possibility that models can degrade at any time. So you have to invest in making sure that this good monitoring capabilities deployed to monitor the health and proactively address any issues. So that's another area to invest in.
Yeah, I'd love to jump into that one a little bit more. Monitoring models in production. That's I think a point of emphasis for a lot of organizations right now, but a lot of data science leaders don't know how to start. Sean, maybe I could jump over to you. What do you think data science leaders should be thinking about as they're working to monitor production models at scale?
To monitoring them at scale is a question I've been fighting over the last 3 months, honestly. And we put 50 models out into production in a period of 9 months, all right? And we have demands from the business to replicate that. So I've got 50 models in play. How do I maintain their value while at the same time delivering new value? And some of the things that we're putting in place right now are more of looking at those statistical metrics on top of what we've done with the stats. And I mentioned that earlier. They're doing data science on data science, all right? And that's looking for different bias, looking for error terms that are occurring, looking for shifts and drifts, and going on the front end of that, looking at the data quality, is that being maintained in the back end? And one of the things that we've done with our technicians is we actually give a model confidence value. So I may give a prediction as to when something's going to fail, but I'm going to also give a model confidence. And that's a variety of elements of another model that we built. And so these two models together can help the technician actually identify that, all right, it's going to fail in 30 days, for example, and everything's coming across as green. I should trust this. And then they can go in and dig in, and we can work from there with them. So that's one of the strategies that we've played, and I think it's been very effective.
That's great. Really good insights. Thanks for sharing that, Sean. And this whole concept of model velocity, like I said, I think that's what's going to separate the winners from the losers over this next decade. I mean, everybody is trying to work on their data. I mean, you mentioned that as being a really important foundational aspect. Most everybody knows that, hey, we should be building models, and they are building models. But how can we really accelerate that model velocity? And there's a lot of great options out there for both validating, monitoring, and deploying and building these models. A lot of great companies are working on it. At Domino, we're working really hard on that as well. This has been a great conversation. Thank you both, Sean and Mina, for joining. Hopefully, audience, hopefully you found this useful and beneficial to you and have some things you can take back to your organizations and to work on that model velocity and work on adding real value, getting real value out of your data science projects. All right. Thank you both. Thanks for joining today.
Thank you, Josh and Sean. Pleasure chatting with you.
Yes. Thank you, Mina and Josh. Pleasure.